Declarative agent configuration serves as the primary mechanism for decoupling model orchestration from application logic within Pydantic AI. By leveraging the agent from spec factory method, we are establishing a structured bridge between static configuration dictionaries and strongly typed dependency injection. We will be examining how to map a data class to an agent's depth type, while utilizing template strings to dynamically inject context into the agent's instructions. This approach ensures that your agent remains type-safe and context-aware, providing a clean interface for initializing complex behaviors through a single dictionary definition. From data classes, import data class. From Pydantic AI, import agent. At data class, class UserContext. Username, SDR. Agent equals agent from spec. Model, Anthropic Claude Opus 4.6. Instructions, you are helping username. Capabilities, web search, local, DuckDuckGo. Depth type equals UserContext. This code demonstrates the declarative construction of an agent using the agent from spec factory method. By passing a dictionary configuration, you decouple the agent's definition, such as its model, instructions, and capabilities, from the core application logic. This approach is particularly effective for teams that need to manage agent behavior through external configuration files or dynamic runtime specifications rather than hard-coded Python objects. The depth type parameter enforces static type safety by linking the agent to the UserContext data class. This ensures that any template strings within the instructions, such as username, are validated against the defined dependency structure at construction time. By using this pattern, you gain a robust way to inject runtime context into your agent while maintaining strict type checking and IDE support throughout your development workflow. Let's break it down line by line. From data classes, import data class. Imports the data class decorator from the standard library to enable the creation of classes that primarily store data. From Pydantic AI, import agent. Imports the agent class from the Pydantic AI package to provide the primary interface for interacting with LLMs. At data class, class UserContext. Defines a data class named UserContext, which serves as a structured container for holding user-specific information. Agent equals agent from spec. Initializes an agent instance by invoking the from spec class method, which constructs the object based on a provided configuration specification. Model, Anthropic Claude Opus 4.6. Sets the model key to Anthropic Claude Opus 4.6, identifying the specific LLM provider and model version to be used for agent operations. Instructions, you are helping username. Defines a key-value pair within a dictionary, where the instructions key maps to a string template that dynamically inserts the username variable. Capabilities, web search, local, DuckDuckGo. Defines a capabilities dictionary entry that enables web search functionality using the local DuckDuckGo provider. This configuration assigns the search capability to the agent, specifying the local search implementation as the target for web-based queries. Depth type equals UserContext. Specifies UserContext as the required type for agent dependencies, enabling static type checking for the agent's dependency injection system. Declarative configuration via agent from spec transforms agent definition from a hard-coded task into a structured data contract. By mapping the UserContext data class to the depth type parameter, you create a rigid type-safe bridge that validates your template strings against your application's data model. This approach effectively decouples the model orchestration and capability definitions from your core logic, allowing you to manage complex agent behaviors through external specifications while maintaining strict IDE support. Ultimately, this pattern treats your agent configuration as a first-class data structure, ensuring that runtime context injection remains predictable and type-checked throughout the development lifecycle.
Typed dependencies steer the agent through web shadows, anchoring fleeting instructions to the name of a hidden guest.